This table shows the percent of U.S. population that is foreign born. Let's look at the next pages to see what we need to do. Create a scatter plot of the data with x equal to the number of years after 1900. Notice it's after 1900, so we'll have to get that right. There's a appear the data can be modeled with a quadratic function. Find a quadratic function that's the best fit, x equal to the number of years after 1900. Does it seem like a reasonable fit? Use the graph to estimate the percent for 2015 and use the graph to find when the foreign-born population is 9%. So we have lots of things to do. They said we would be doing years after 1900. So this will be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 105, 107, and 108. We'll have to remember those and using these as foreign born. So we'll have to go to our, now we have all the data entered. We'll set a window. Our x values went from 0 to 1008, so or 108. So let's choose 110. Our y values went from 4.7 to 14.7. So let's use 0 to 20, I believe makes sense. And here's our graph. So we have our scatter plot. Have our graph ready. We know that we use this as 0, 0 to 110, and 0 to 20. And the question, does it appear the data can be modeled with a quadratic function? I would give a yes for that. Next, we want to find the quadratic function that is the best fit. At CAiC, we are looking for a quadratic function, so that is number 5. I'm going to assign a y variable there, our function, and we'll save it in y1 and calculate it. So there's our function. A is 0.003 to the nearest hundredth. B is negative 0.322, and C is 16.657. We do all of those to the nearest three decimal places. So we found out our function was y equals 0.003 x squared minus 0.322x plus 16.657. So these were all to the nearest hundred. Does this seem like a reasonable fit? Well, let's check that. And then next we'll be doing works. Does it seem like a reasonable fit? Let's go back to our calculator. Might be a reasonable fit. You notice it doesn't go through all the points, but it comes kind of close to all of them. So it's not a perfect fit, but a reasonable fit. To estimate the percent in 2015, so we can do that two ways. First, we would do it graphically or algebraically. Y equals 003. 2015 would be x would be 105 for years after 1900 squared plus or minus 0.322 times 115 plus 16.657 up to equal 19.302. So that says in 2015, 19.302% of the population would be foreign born. I'll do second calc. It's a value, so 1. We'll say x equals 1, 1, 5, and enter that. And we get 13.6505. So 13.7. Equation we found a much different answer than our 13.65. And the reason that happened is you can see what a long value we used when we had rounded with our calculation, and we found out a much different value. Now we need to use the graph to find when the foreign-born population was 9%. So we're going to put a 9 in here for y equals 9. If we'll go to our graph, we'll find we have a line across, and when y equals 9. Now the directions, we want an intersection 5, and we can see there's when x is 60%. Do an enter. On the other curve, x is 60%. We really have 2 points, so let's take a guess at this one first, and we'll take a guess at 30. Enter. We'll find out that it's 31.69. We can round that to 32. And then we're going to do that again. Second trace. We want the intersection. This time we're going to do a guess over here. And we're going to guess, let's see, 60 was about here. So let's guess 90. And we'll find it's 93.2. So we had 32 and 93. In our graph, when was the foreign-born population? 33 or 32 for years after 1900 would be in 1932 and was 93, so 1993 was when we would have a 9% foreign-born population.